Now that we've looked at what an exponential function is, and we've looked at what exponential growth and decay are, we're going to look at exponential growth functions that are used in real life situations. And one of the most common is compound interest. Okay, when interest is paid monthly, for example, the interest earned after the first month becomes part of the new principal for the next month. Interest is then earned on the interest that you just earned. Okay, this is compound interest. Interest paid only on the principal is called simple interest. You might have used this formula I equals P times R times T in Algebra 1. We're now going to look at how compound interest is calculated. Okay, so we have a formula here, and I'm not going to ask you to memorize that formula. I will give that formula to you, but I do expect you to be able to use it correctly. Okay, P is the principal amount. That's the amount that you would originally invest. R is the interest rate written as a decimal. N is the number of compounding periods per year. And A is the value of the account after T years. T is time in years. A is the amount of money that you then accumulate. So we wanted to look at the difference of how compounding more often within the annual year makes a difference. So if something is compounded annually, your N value, or the number of times compounded, is just 1. Annually means 1. If I compound semi-annually, well, that means I'm going to do it twice a year, and so N is equal to 2. If I compound it quarterly, to do it quarterly means 4 times. Okay, there's 4 quarters in a dollar, or there's 4 quarters in a basketball game or a football game. So quarterly means 4. And if I compound monthly, that would equal 12. Every month, there's 12 months in a year. You might also encounter something that's compounded daily, and if it were daily, that would be 365 would be your N value. So we're going to use the same formula over and over again. It's just the value for N is going to change depending on how often I compound the value. Okay? So if I want to compound, I'm going to use this compound interest formula. And if I want to find, it says Tamira invests $5,000 in an account that pays 4% annual interest. How much will there be in the account after 3 years if the interest is compounded annually, semi-annually, quarterly, or monthly? So here's her initial value. That's your principal. That's your P. It pays 4%. Now remember, we don't put percent in. We put it in as a decimal. So this is going to be 0.04 for R. And then here's your time is 3 years. Okay, so when you plug that into that formula, you're going to say $5,000. Oops, I'm a 0 short there. We're going to put $5,000 in. Okay, we've got 1 plus rate divided by N. Our rate goes in as 0.04. Our N is just 1 because it's being compounded annually. And then out here, this is NT, that's N times T, so 1 times 3. And that would be the formula that you would use. And again, you want to follow order of operation. So inside parentheses, we have to evaluate this. We would take 0.04 and divide it by 1. Anything divided by 1 is just going to be itself. So this would be equal to 5,000. Okay, that would be 0.04 plus 1. That would be 1.04. And then I can multiply outside the parentheses. 1 times 3 is 3. So just like the previous section, you're going to want to take this 1.04, raise it to the third power, and then take your answer times 5,000. Okay, I didn't write down the amount of money that I have on that, so let me grab my phone here, and I'll tell you what that dollar amount should be. I'm taking 1.04. I'm going to raise it to the third power, and don't round that decimal. We're just going to take it times 5,000, and we get a value of $5,624.32. Okay, and that's, since it's money, we're rounding to the nearest penny. And so we're going to do the same thing for each one of these in our table. Okay, if I'm going to jump down here to quarterly, if I were to evaluate the same situation, but we're going to compound it quarterly, the only thing that changes in my formula is 1.04 0.04. Instead of dividing by 1 like I did for annually, for quarterly we'd be dividing by 4. And then outside the figure, we'd be taking 4 times 3. 4 is the number of times we compound it. 3 is the number of years we're looking to evaluate. Okay, when I take 0.04 divided by 4, in that case I get 0.01. 0.04 divided by 4 equals, okay, I have to add 1 to it. Okay, next thing I'm going to do, I'm going to raise it to the 12th power this time. 4 times 3 would be 12. It's going to be raised to the 12th. And then you take that decimal times your $5,000. Equals, this time I get $5,634.13. And you can see I earned more money when it was compounded more often. And that's what you're going to find. You're going to find the largest sum on this is going to be on the bottom row where you're compounding monthly. That's because every time you recalculate that interest, it makes your principal amount bigger. So your dollar amount is going to be bigger. Okay, we've got the same situation here at the bottom. We're going to ask you to calculate annually, semi-annually, and quarterly. Okay, I'm using that compound interest formula at the top. This time I'll do a semi-annually. If I invest $3,000 in an account that earns 3% annual interest, what's the value of the account after 10 years? So $3,000 is my principal amount. I've got to put 3% in as a decimal, so I put it in as 0.03, and time is 10. So I would say my amount is going to equal 3,000 is my principal, 1 plus, I put the interest rate in as a decimal, I divide it by the number of times that I'm compounding, semi-annually, n is 2, and I raise it to the n times t. T is 10 in this time. Notice that n goes into both of those spots in the formula. Okay, this is going to be $3,000 times, if I take 0.03 and I divide it by 2, okay, that's 1 plus 0.015, and I can multiply 2 times 10 and I get 20. Okay, so I'm going to do what's inside parentheses. I'm going to add those together. I'm going to raise that to the 20th power. It equals, and I get a big long decimal. Don't round that decimal. Just take it times 3,000. Okay, and I end up with a value of $4,040.57. $4,040.57. Okay, if you're having trouble getting those values, email me or get a hold of me. So it might be in your process. Make sure you follow PEMDAS with this. Make sure you're using the right formula. Okay, now that's compound interest when it's compounded either annually, semi-annually, quarterly, or monthly. We also have a situation where we have interest that is compounded continuously. And if you see continuously in the context of a problem, then we're going to use a different formula. We're going to use, we call the PERT formula. A equals P, E raised to the RT. Okay, this E value right here, that's a natural log. Okay, we have not used that before, but E is very similar to pi. You know, you've used pi before in math. Pi has a value of 3.14159, and it goes on and on and on. We round it off to 3.14, and we use that value every time pi is involved. Well, E is like pi. E has a value of, I believe, 2.71, and it keeps going. It's also an irrational number. So we have this letter E. It has a value to it, a mathematical value to it. But here's how we use it in a interest formula. Okay, if I want, it says Regina deposits $2,500. That's still your principal. That's still P. The rate of interest is 5%. We're still plugging that in as a decimal, 0.05. And it's asking us to find the value after 2 years. 2 would be our time value. So when I plug this in, I'd say my dollar amount is $2,500. Okay, then E, and then R is 0.05 times 2. Okay, we're multiplying the rate times the time there. Now, when you use on your phone or your calculator, you're trying to evaluate E, Okay, we're going to need our phone on, you're going to need the bigger calculator, but you want to evaluate this exponent first. So I'm going to say 0.05 times 2 equals, I get the decimal point 1. Okay, so at this point, and I don't need to do anything with my calculator, but that's e raised to the point 1. To evaluate that, you should have a key on your phone that says e to the x. And you have that on my calculators as well. The sequence of putting it in might be a little bit different depending on your calculator, but for phones, for my phone anyway, I evaluate that point 1 and then I just hit my e to the x key. And that automatically takes e to that power. I have a decimal there, I don't round it, I just hit times 2500 and I hit equals. Okay, that value after 2 years is going to be $2,762.93. Okay, $2,762.93. Okay, if I want to evaluate the same thing at 5 years, I'm still using the same principal amount. So A is going to be 2,500 still. E is still there. Okay, this time my interest rate is still 0.05, but now I have to take it times 5. The only thing that has changed is my time, my amount of time. And again, when E is involved, you're going to want to evaluate that exponent first. So I say 0.05 times 5 equals, this is 2,500 e raised to the 0.25. And again, for your phone and for my white calculators anyway, you evaluate that first. And now from there, you're just going to hit the e key, e to the x. It's evaluating that e to that power. And then you want to hit times 2,500 in this case, because that's the principal amount. Okay, this value at 5 years, I'm going to erase my work here. This value at 5 years is going to be $3,210.06. And I'm just going to quickly, you can pause the video and you can evaluate your last one. I'm going to do it real quick here and just put the value up there for you so that you can see what it is. Okay, and if you do the last one, you're going to get $3,637.48. Okay, if you're not getting that, make sure you ask questions, and that's how the PERT formula is used. So you've got two different formulas you're using. You've got your compound interest formula, and you've got your continuously compounded interest formula. If something's compounded annually, semi-annually, monthly, quarterly, you use that original at first compound interest formula. But anytime if in your context it says it's compounded continuously, that's when we switch and we use the PERT formula. All right, there's a worksheet for you. Give that a shot.